Yes,
How are you, Apiri?
I'm okay.
What about Sandra? Sandra, how are you? Sandra, can you first unmute, please?
I'm fine.
You're fine, eh? Now, Sandra, I failed to get the other question. What should we do? I failed to get it. Do you have it?
No, I don't have it. Those are my just wrote it from school.
I thought maybe I had a question here, but I've tried to check it in my file. I'm not seeing it. Hmm?
You've not seen the question, or it's not there in the question paper.
I'm not seeing the question paper itself.
Hey.
Maybe I will check from the warden in from the library. Hmm?
Okay.
So I will check it. Then I will, if I get the question, I will post it on the on physics WhatsApp group. Okay. Okay.
Okay. Yes.
Okay. Nakachwa. Nakachwa.
Yes, teacher.
Brenda.
Yes.
How are you? Wherever you are.
Yes.
How are you?
I'm fine. Good morning, teacher. I'm fine.
Where are you?
I'm home.
Of course, I know you are at home. I know I'm not teaching someone who is in the bush. Which part of the country? Which part of, because Apiri is in northern Uganda. Sandra is just in Bogorobi. And you?
I'm just in Luzira.
Just here in Luzira. Okay. Okay.
Yes.
All right. So last time we met, we discussed this. I think there is no problem on experiments now, on how to explain the laws, on how to describe the experiments, and to determine the coefficient of kinetic friction and for static friction. I told you the problem here was supposed to be capital M over small m, was supposed to be like this: mass of the scale pan plus the mass added over the mass of the wooden block. So it's supposed to be capital M over small m. So we have seen also for kinetic friction, where we say you keep on adding the masses until the block move with a uniform speed, And we have seen that. This one will give us this as well. Will give us this. The formula will remain the same. So let's go through some of the questions here. Like example number one. They're saying a track of mass, 10 tons, moving at 10 meters per second, draws into a stationary track of mass, which means they will stick together. Draws into a stationary track of mass, 4 tons. They stick together and skid. To skid means to move, which means they will deviate from where they are. They will change directions. Which means they will lose track. What do I mean here? They will lose track. They will take off in a different direction. To stop along a horizontal surface. So that now they want us to calculate the distance. Through which the track skid if the coefficient of friction is 0.25. So which means it's not a smooth surface, So there's friction there. So which means we have to consider the frictional force. When we are doing the calculation. So let's look at the solution for that. So we have two tracks. We have M1, which is it for 10 tons, which is same as 10 what? 10,000 kilograms. Then we have M2, which is stationary. This one, we can say this is MU. Let's call this one U1. U1 is 10 meters per second. Then M2 is 4 tons, which is the same as 4 kilograms. Then U2, they said is stationary, which means 0 meters per second. Just a minute, members. Just a minute. Let me pick something. Good. Good. Members, are we together? Members, are we together?
Yes.
All right. So we have collected information. So they said they were moving together. Which type of collision is that? Which type of collision is that, members? So type of collision, you also must take note of that. They may ask you for that. Type of collision is going to be in elastic what? In elastic collision, because they stick together, which means they will move with a common and move with a common velocity and move with a common velocity after impact. After impact. So let's have the sketch of that. So if this is the road, this is the level road they're talking about. This is the level road. So you have two tracks here. So this is that. Then we have this. Like that. So this is our M1. So it's moving in this direction with U1. So this is M2, which is stationary. So after they will stick together, and move with a common velocity, like that. So they will stick together like that. So this is M1, this is M2, and move it now with common velocity V, So this is before, and this is after. So the first thing here we have to find this velocity V. So we said from law of conservation of linear momentum, which means total momentum before collision must be equal to total momentum after collision. So we shall have M1 U1 plus M2 U2 equals to M1 plus M2 times the common velocity V. So which means our V will be equals to M1 U1 plus M2 U2 over M1 plus M2 plus M2. So V will be equals to, so we shall have 10,000 times 10 plus 4,000 times 0. Everything is over 10,000 plus 4,000. So we find that our V will be equals to, so here we shall have 100,000. Shall have 100,000 over, this is 0. So this will be 1,400. So therefore our final velocity V will be, so we have 100,000 divided by 14,000. So we get 7.14. Is that what you are getting, members? 1.4229. Sorry, 29. Let me write here 7.1429 meters per second. So this is it to 4 dPs. So now we have got the common velocity with which they were moving at. But when you look at the question is they want us to calculate the distance through which the track skid. So which means this one, there will be friction here. Before, there will be friction here, only here, because after skidding. So this one they were skidding. After moving together. So which means there will be frictional force here. So let's call this one mu. We know frictional force is given as mu R. So when they're skidding here, there will be normal reaction. Normal reaction created here. Normal reaction will be there, R. Then here there will also be weight. They will be exerting weight because frictional force is experienced due to weight. So this one will be M1 plus M2 G, because they're moving now with a common velocity. V. Are we together, members? Are we together? Brenda?
Yes.
Brenda, are you following me?
Let's repeat.
Which one? Which one?
That one
Yes,
of weight.
teacher.
Okay. We are saying, because they're saying, when you look at the question, they say they stick together and skid to a stop along horizontal, which means it was after impact. They started skidding after the impact, which is here. So, and in the process of skidding, because they are moving now together, they will experience what we call kinetic friction. There will be kinetic what? Kinetic what? Friction. Kinetic what? Friction. When they were moving together, not before. So that's what they are saying. So the kinetic friction was given to be, so kinetic friction mu k was given to be 0.25. So that was the kinetic friction, which is going to be experienced after collision, after impact. So which means we know that the first friction depends on the normal reaction. It's direct proportional to the normal reaction. So we shall have this one, mu and r. So let's find that friction. Let's get the frictional force. So the frictional force exerted on the system of colliding bodies, So our frictional force will be, let me use small f equals to mu and r, but r will be equals to m1 plus m2 times the acceleration due to gravity when they are moving together now, the total mass, the combined mass of the two systems. So frictional force F will be equals to, our mu was given, so we shall have mu into m1, m2 times acceleration due to gravity. So F will be 0.25 time, this one we said is 14,000 times 9.81 So F is equals to, can you get for me that answer? So we'll have 0.25 times 14,000 times 9.81. What do you get? Members, what do you get? What do you get?
Teacher.
Yes?
Okay, then in the question you say that. Okay, so I've seen where they got it from.
Okay, thank you. So which means here we shall have, when you calculate this one, is 34,335 what? Newton. So that's the frictional force. That Brenda, your network, Brenda, your network. But Sandra, is this what you get?
Yes, I've got that.
Okay. So can we proceed now? Now, first, because now they want distance, which means we must go back to what? We must remember equation of motions. You must remember equation of motions and from Newton's second law of motion. So from Newton second law of motion, because they're in motion. So we said F is equals to ma. So we have to find the rate at which they were accelerating at. But we know F is a resultant force. So when you look from our diagram here, is there any other force acting this side? Is there any force acting this side? No. So the only force that is acting in this direction is the frictional force. So the single force acting here is acting on the system is the frictional force, which we have got is so it will be resultant force, which is F equals to mass of the two systems combined, m1 plus m2 times the acceleration that we are looking for. So frictional force is 34,335 equals to 10,000 plus 4,000 times the acceleration that we are looking for. So we shall have 34,335 equals to 14 14,000 A. So divide all through by 14,000, divide all through by 14,000, divide all through by 14,000. So this and this will cancel out. Therefore, our acceleration will be 34,335 divided by 14,000. So we shall get what? 2.4 525 meters per second squared. Do we stop there? They want us to find the distance. They want us to find the distance. Now they're saying, we should remember that whenever there's frictional force will bring the stop, will lead to the what? To the stop. So which means the body will be decelerating. It will be what? It will be decelerating. So we said when they stop, it implies that the tracks were what? We are what? We are retarding. We are what? We are retarding. So which means acceleration will be negative. This one will be, we attach a negative value there, which is 2.525 meters per second squared. Where the negative is coming from, because they said there stops, which means it was decelerating. So that's why we have to put this. We attach the negative there. That negative is very important because there's frictional force acting on the system. Because there's frictional force acting on the system. So now, using the equation of motion, you're using equations of motion. Which equation are we going to use? Because we want to find distance, members. Which equation are we going to use? We don't know time.
Yes.
We are going to use? We don't know time. Time was not given. So we are going to use the third equation, not sir? Yes. So from v squared equals to u squared plus 2a as.
Yes.
Which means s is equals to v squared minus u squared. Wait. Is it going to be like that? Yes. Over 2a. Over what?
2a.
Over 2a. So let's substitute. What will be our v? What is our v? It was brought to rest, which means the final velocity of the system will be what? Will be 0, not sir? The track was brought to rest because they said it stops, which means the final velocity will be 0. The final velocity will be what? Will be 0. So, but the tracks were brought to rest. Or to stop. So implying that the final velocity will be 0 meters per what? Will be 0 meters per second. Then what will be our u? U will be the speed at which the common velocity which they were moving at, the common velocity, which we got 7.14. We got what? Let me see. What is the answer? What did we get? We got
7.1429.
Yes, meters per second. So when we substitute now, our distance s will be equals to, this is 0 minus into 7.1429 squared over 2 times our acceleration, which is negative. We got negative what? Negative 2.4525. So what do we get? So S is equals to 7.1429 plus squared divide by into 2 times 525. What do you get? It's going to be 7.1429 plus squared. Then divided by 2 times 2 times 2.4
Negative 10.
to 5. What do you have?
Negative 10.4018.
Will the negative come in? This one, the negative is here. This negative will cancel with the negative, which is coming down here. I think that's Sandra.
No, for me, what I did, I multiplied it with this 7.1429. Then
Okay.
it will become a positive. Then down here it will be a negative.
Okay. So the final
That's
answer is
I
what?
did.
Is 10 point what? 10 point? 10.4.
4018.
018. Like that. What? Meters. Meters. So that's the distance they wanted us to calculate. That's the distance they wanted us to calculate. Brenda and Apiri, are we together? Brenda and Apiri.
Yes, sir.
Yes, teacher.
Okay. What do you think? Which other
Excuse
question?
me, teacher.
Which other question do you think they can ask on this very question here? What do you think they can ask?
Teacher,
Yes?
but I'm still getting a negative. I don't know why.
Excuse me, teacher.
Yes?
I think the answer is a negative because
Yeah.
when a negative is squared, it becomes a positive.
No, you are squaring
And
on it.
this,
You are squaring on it. You are not squaring. This U is not a negative. That's why I said 0 minus into 7. So when you square only this negative will still be there. So which means here you get a negative value over this one. You also get you a negative,
Suppose
a negative. So a negative divided by a negative, you get a positive.
okay.
The negative is not on this one. U is not a negative. This is not negative. This one is not negative. It's a positive.
okay.
Okay?
Okay.
Yes. Please let me hope you have seen it.
Mm.
Okay. Another question they may ask you from there, they may ask for the work done because our next topic is work done. So if they ask you for work done, we know work done is what? They may ask you to find the work done. So let's add part B, calculate, because this thing is a calculate the work done by the system. Calculate the work done by the system. We know that work done from our O-level physics, we know work done is equals to force.
Force times the distance.
Force times the distance. Force times the distance. So they may say calculate the work done by the system due to frictional force. Due to frictional force. Due to frictional force. Due to frictional force. So which means this force will be what? Frictional what? Will be due to frictional what? Force. So our work done will be equal to the frictional force we got. What was our frictional force?
34.335.
33 times the distance we have got is what? 10.4018.
10.4018.
So what is the answer? Members, what do you have? Do you have 300?
357.1458.
5
Joules.
0.80 what? 3 joules. Not so? Not so?
Yes.
Or someone you can put it in standard form. If you put it in standard form, it will be. If you put it in standard form, it will be 3.57. Not so? Times 10. Yes.
I said 357.1458.
Sure. Check your calculation.
Like
check. That is not a point, it's a comma. That is a comma.
yes, it's a comma.
It's 350 what? 7, 140, 45.8.
803.
Yes. Sandra, check that. So when you put this one in standard form, what do you get? To the power what? To the power 5 joules. So that's the work done. Work what? Work done due to frictional force. Work done due to frictional force. Members, are we together?
Yes, teacher.
So the rest are just walk over. The rest are the same. 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 Just a matter of resolving. We have seen how to resolve forces. So whenever there is frictional force, we should know how to resolve it. So let's go to horizontal inclined plane. Let's look for inclined plane. Members, I think number 2 we can do it now. Not so. Number 2 we can do it. Not so?
Oh my goodness. Oh.
Members, can we do number 2? So in number 2, the only thing that you have to do there is just to convert the 72 kilometers per hour to meters per second. To meters per second. Okay, let's work out number 2. Let's work number 2. Let's work it out. We have only 1 minute remaining. We have only 1 minute remaining. So question number 2, they're saying a car of mass 1,000 kilograms moving along a straight road with a speed of 72 kilometers per hour is brought to rest by a speedy application of brakes in a distance of 50 meters. In a distance of 50 meters, find the coefficient of kinetic friction between the tires and the road. Between the tires and the road. So let's collect our information. So we have the mass. Mass was given to be 1,000 kilograms and is moving at the speed of u was given. The speed was given is given to be 72 kilometers per hour. So I've already told you how to convert this one direct from the calculator. So there's no marks for converting this. So just convert it direct from your calculator. I said if you want to convert, you look at the constants here. We are converting kilometer per hour to meters per second, and it's number 19. It's number 19. So what we do, we first press 72, shift, convert, 19. I think what is going to display on the screen. I think what is displaying on the screen, members. I think that. Then press equal sign. So which means 72 kilometers per hour is the same as 20 meters per. Is the same as 20 meters per second. Remember, have you seen how you convert? Members, have you seen how you convert? Yes? Okay. So we shall join back and then we continue, please. We shall join back and then we continue. Which other information have they given us? Is brought to rest